So we've got another question on the kidney, as promised. This one is about ADH. So ADH, as you know, stands for antidiuretic hormone. It binds to receptors that are found on cell surface membranes in two parts of the nephron. Can we name the two parts where we would find the receptors for ADH? So again, let's just do a quick sketch of our nephron. Okay. Now, the receptors for ADH are found in these last two regions, okay? So they're found on the epithelial cells that line the DCT, or the distal convoluted tubule, which is this bit here, yeah, the second convoluted tubule, or the most distant convoluted tubule from the Bowman's capsule. They're also found in the final part of the nephron, which is here, which is obviously the collecting duct, okay? So they're the two places where we find the receptors for ADH. And ADH will bind to the receptors on those epithelial cells, and when it does, it obviously causes the reabsorption of more water into our bloodstream, makes our urine more concentrated. So V receptors only bind with ADH, suggest and explain why. This is really a question just about proteins, because ADH is a hormone that's made from protein and the receptors are also made from protein. So really what they want you to say here is the proteins. Now you could refer to either because they're both proteins, but I'm going to refer to the ADH. The ADH, the hormone, has a specific tertiary structure, but you also could have said the receptor has a specific tertiary structure, right? They're both proteins. The mark really is for the phrase tertiary structure. And the second thing to say is the ADH is complementary to the receptor. And the mark there is really for the word complementary. So that's why this hormone will bind to those specific receptors that are found on the epithelial cells of the DCT and the epithelial cells of the collecting duct, because their tertiary structures are complementary.